Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the properties of inverse matrices, and then we shall be looking at perhaps two examples related to that. Okay, so here is a bit of definition. Let's say A is an invertible matrix, K is a positive integer, and C is a non-zero scalar. Therefore, it says here that the inverse of A and then the matrix A that is multiplied by itself up to k times. So here is basically A times A until k times. So here is like k times. And then C, which is a constant, multiplied with the matrix A and also A transpose. So all these things here are invertible as well, and give results to the followings where these are all true. So the first property says that if you have inverse of matrix A and then you consider finding the inverse of that, you will get back the original matrix A. For the second property here, you can see that the process here is you will do the one in the bracket. That means you will go on and multiply matrix A with itself up to k times. So this is the process. You multiply A with itself according to this value, how many times. So you do it up to k times. Once you get the result, then only you find the inverse of that result. So what it says here is that the process on the left hand side here is equal to this process, where instead of doing or instead of multiplying A with itself up to k times, what you can do is you can find the inverse of a matrix and then multiply the result up to k times. So here is you do the multiplication of the inverse matrix of A up to k times, and so it can be written in this way. So this is the inverse matrix, and then you multiply that result with itself up to k times, and the result here will be equal to the left hand side given there. Now for the third property, this is a constant multiplied with A. So once you get the result, you can find the inverse of it. And this process here is the same if you consider taking out the bracket. And so if you consider taking out the bracket, therefore here we have 1 over C, and then it will be multiplied with the inverse of matrix A. So this is the part that is a bit different here. It will be 1 over C. This is inverse of matrix A. And the last property says that if you have A transpose and then you find the inverse, the result is the same thing if you find the inverse first and then you transpose the result. Okay, so the result should be equal. Okay, so let's look at this example here. We are going to compute this matrix in two different ways and show that the results are equal. So how can you compute this value right here? So here A -2. This is the same thing if you consider A 2, this is -1. Or you can consider it to be as such. Okay, and which property are we referring to at this moment right now? We are actually referring to this second property. Okay, so let us try and do this part first. This is equal to, so that means we're going to consider solving the one in the bracket. So here we will have, sorry, hang on. So maybe what I can do is Oops. Okay. All right. So what I can do is, well, let's just focus on finding A, and you square the matrix, you multiply the matrix with itself. So here is 1, 1, 2, 4, multiply it by itself. And here is, well, 1 times 1 plus 2 is 3. And then 1 plus 4 is 5. 2 plus 8 is 10. 2 plus 16 is 18. So this is doing or focusing on this process first in the bracket. Now once you get the result, therefore you can find the inverse of that matrix following this formula. Okay, so we all know that this is A, this is B, this is C, and this is D. Therefore, what we have is A times D. So 18 times 3 is 54 minus 50. And here, D and A will switch places, 18 and 3. Here, we will assign negative to B and C. So here we have negative 5 and negative 3. Okay. Right. I'm running out of space actually, so perhaps I have to erase this first. Okay, so now I'm just going to continue right next to it here. So therefore, the whole thing here is equal to 1 over 4, 18, negative 5, negative 3, and 3. And this is equal to, well, 18 over 4 is actually equal to 9 over 2, negative 5 over 4, negative 3 over 4, and 3 over 4. So this is the result for this part that we are looking for. Compute A, and here we have negative 2 in two different ways. So the first way is by considering first multiplying the matrix by itself, and then only you find the inverse of the matrix. Now let's focus on doing it the other way. Okay, so the other way is, well, I'm just going to write down the result here. So, oops. Okay, so therefore, this is the result as such. 9 over 2, negative 5 over 4, negative 3 over 4, and 3 over 4. So this is the result that we got using this way. And now our job is to show a different way of getting the result. So a different way would be to consider finding the inverse of this matrix, and then you multiply the result by itself. Okay, therefore, inverse of this matrix, according to the formula, is this one. This is the formula. And A times D is 4 minus 2. Okay. Next, we switch the places of D and A, 4 and 1. So, and then here we assign the negative signs, so -1, -2. Therefore, the inverse of matrix A is, this is 1 over 2, and the matrix can be 4 over 2 is 2, -1 over 2, -1, and here will become 1 over 2. So this will be the inverse of matrix A. Okay, so therefore the inverse multiplied by itself is going to be 2, -1 over 2, -1, 1 over 2, 2, -1 over 2, -1, 1 over 2. So here we have 2 times 2 is 4, 4 plus 1 over 2. So that will be 9 over 2. -1 minus 1 over 4. So -1 minus 1 over 4. Sorry, so here is 2 times -1 over 2 is -1. This one is -1 over 4, yeah. So that will be -5 over 4. This one is -2 minus -1 over 2. So that will be -5 over 2. This is 1 over 2 plus 1 over 2. It's going, sorry, this is 1 over 2 plus 1 over 4. So that will be 3 over 4. And as you can see, the result here is the same. So the result here is the same as what we have already obtained here using a different approach. So again, for this one here, we consider multiplying the matrix by itself and then finding the inverse. But for this one, we start off with finding the inverse and then multiply the result by itself. Okay, next example, or next theorem. Well, if A and B are invertible matrices of size n, then AB here is invertible because it says here A is invertible, B is also invertible. Therefore, the product of these two matrices is also invertible, and we have this equation here where it says you can consider multiplying this product first and then find the inverse of the result. And the result here on the left hand side will be equal to what is given on the right hand side. So basically, if you want to consider taking out the bracket, therefore you're going to switch the position of B and A. So here we have the process of finding the inverse of matrix B multiplied with finding the inverse of matrix A. So again, just be careful when you want to consider taking out the bracket, then the position of matrix A and B will be switched. Here we will have B, here is the inverse of B, and here is the inverse of A. And of course, this theorem can be generalized if you have many different invertible matrices. For example, here we have n different matrices. So here is the first matrix, the second one, and the nth one. So they are all in this nice bracket, and outside here then you have the inverse process that you have to do once you get the result inside the bracket. Or if you want to do it in a different way, you want to consider taking out the bracket, what you can do is you're going to put this last matrix to be at the first position, and then you find the inverse of that matrix. So here is the last matrix, and you're going in that order. So A2 here is the matrix here will be at the second last position, and this is the first matrix here, but it will be at the last position. When you take out the bracket, you will switch the position. So similar to the idea of this given statement here. Okay, right. Now let's look at this example here where you have B is said to be an invertible matrix. That means you can find what is the inverse of it, of that matrix. And A is any matrix where you have this statement is to be true. So this statement is assumed to be true. A is any matrix such that when you multiply with B, the result is going to be the same when you multiply B times A. So changing the position doesn't affect the result. The result is going to be the same. Therefore, we're going to show in this example here that A and the inverse of matrix B commute. So what does it mean really? So it means that we need to show that A and B, so it is this process, inverse of B, is equal to inverse of B matrix times A. So this is what we need to show. So need to show, and our starting point will be based on this given statement, because this statement is already true. Okay, so therefore based on the statement where AB is equal to BA, what we can do is we can multiply each left hand side and right hand side with the inverse of matrix B. Okay, so that's what we're going to do. We're going to multiply. So multiply both sides with inverse of B. Okay, so therefore, we will have right here AB multiplied with inverse of B will be equal to BA multiplied with inverse of matrix B. And this times with this is going to be an identity matrix. So A times with identity matrix. And here what we can have is, well, we will have B times A. This is the inverse of matrix B, and that's all that we can do. We cannot do much right now. Right, next what we can have is A times identity matrix is just going to be A, matrix A. Okay, right, now what we're going to do is we're going to multiply both sides with inverse of matrix B. So again, we're going to do this multiplication process, multiply both sides with inverse of matrix B. Therefore, what we will have is we can consider inverse of B to be on this side, multiply with A. So inverse of B, B, A, B, inverse of B here. This part here, when you multiply inverse of matrix B with B, that will give you an identity matrix. Identity A, okay. And identity times this matrix, you will get this matrix back. And if you want, you can switch the position of right hand side and left hand side so that it can represent what we are looking to show right here. Therefore, A times inverse of matrix B is equal to inverse of matrix B times with A. So we can see here shown. Okay, I think that's all for now. Thank you very much for watching, and I'll see you in the next video.